Yeah. So oh yeah. Works maybe. This is the one that's 15x to the fourth, right? That one?
Yeah.
15x to the fourth minus 12x cubed plus blah 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 all over 3x squared. I'm not going to do the whole problem for you, but what's being divided by 3x squared? Every single term up there, so then write it like that. That's being divided by 3x squared. You get a card. Now that's being divided by 3x squared. Blah, 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 blah. And then simplify, simplify, done. You can't do that if the bottom has more than one term, and that's why we had to come up with the long division. Would long division still work here? Of course. But why? Why would you do it? Yeah. That's number 14 in the review section.
The only question I have is like when you put 18 over 3x squared.
Yes. Something weird happens with this one and this one.
You just leave it like that, right?
Well, they both can reduce. You just leave what can't reduce, right? So here, what can you reduce here?
X.
Yeah, an x dies. Where's an x left? On the bottom.
Yeah, so 2x.
Here is 18 divided by 3 is 6,
Right.
and the x squared is still on the. The big mistake is I have somebody tell me the answer to that is this, right?
Okay, so
It doesn't make any sense.
Okay.
Is that decent? Is that?
Yeah.
If it doesn't reduce, it stays where it is. Yeah. Yes.
I have a question on number 11. How do you get 2? How do you add 8? Like, so I was doing it and I was looking in the book and I didn't know how I got
11 from where?
11.
Which homework?
Review.
Oh, the review?
Yeah.
So my 11 says 6x minus 5y squared, is that?
Yeah. Yeah.
Okay. So you're asking, you don't know how they get what now?
Well, no, I got I did it out. So I did 6x minus 5y squared parentheses, and then I broke it down to. Then I multiplied the 2x. I broke them off because it was squared, so I broke it off like that, and then I divided, and then I multiplied. Okay, I did not do that.
Uh-oh,
I
shit.
did not do that. Okay.
Yeah, this is the first thing is something squared.
I squared all of them,
Oh.
and that's what I did. And then.
So, just to make sure I know what you mean. If you saw this and you squared each piece?
I squared like the 6, the x, the 5, and the y.
So you got like 36x squared.
Yes, 36x squared plus 25y squared, and I was trying to figure out how the heck did I get the 16?
Gotcha. So, here's the thing. All right, this is key. I really want this to make nothing but sense. I think I said this before, but I might have said it really fast, like I say a lot of things. What are exponents based on?
What they have?
What are exponents based on? What are they based on? What's 7 squared?
The number
What's 7 squared?
49.
Why?
Because it's multiplied by 7.
Multiplication. So the exponents are based on multiplication. So if this would have been 6xy squared,
Right.
that would distribute totally because exponents work well with multiplication because they're built off of multiplication.
Okay.
Right? If I write 6xy twice, there's no foiling to be done.
Right.
If I write this twice, there is. So there's kind of like a shortcut for when there's only one term inside.
Mm-hmm.
It's all multiplication. The shortcut is you don't have to write it twice. You just square each piece.
Okay. And would you square those up there, both of them?
No.
No.
This squared is this times itself. The same way 7 squared is 7 times 7. So you rewrite this as this,
Right.
and then FOIL it. Yep.
So, when you have an exponent on the outside, the x itself is already x to the 1.
Yes.
Wouldn't you add that to the 2, or?
No.
No?
No. So let's see. So if I had x cubed squared, What does something squared always mean?
So,
That times itself. And of course, then what do you do here?
You add exponents.
You add it. So that's why the shortcut is you multiply.
Oh, yeah, you're
Because
right.
multiplication is, remember how did you first learn multiplication? If I had 2 crates with 3 apples in it, how many apples do I have? 2 times 3, I got 6 apples. Give me one of them. I got 2 crates with 3 X's in each. How many X's do I got? 6 of them. It's the same stupid thing. That's why this is multiplication.
Gotcha.
This really is, real quick, if it was x cubed times x squared, that of course would be,
X to the fifth.
yeah. And people go crazy here. They're like, 3 times 2 is 6. I'm multiplying, and I'm like, there ain't no 3 up here. There's no 3 anywhere in here. There's no 2 anywhere in this statement. Nowhere. And that's, of course, where some of you guys are like, he forgot his meds. Do you guys understand? There is no 3 anywhere in here. What is that? That represents how many x's there are there. There's 2 more there, so there's 5 altogether. I mean, the property only makes sense. It kind of, you got to stop your brain from just immediately going times, 3 times 2 is 6. No, brain, I don't have a 3 or 2. I got 3 x's, 2 more, 5 in the chain. What's really interesting is, let me say this, and if you don't quite get this, it's okay. When you multiply, you add. So it's like one step down from that operation. When I raise, I multiply. Again, it's like one step down. If you don't get that, it's okay.
Oh, yeah.
So that's why here you don't add, because that's too many steps down from raising. Okay. I had somebody a while back, a cheerleader, she said this thing, when you multiply, you add. She added some other shit, but that's the only one I can remember. When you multiply, you add exponents. Anyway. All right. Anything else from any homework?
Yeah, 31 on the review.
We saw one sort of like this. Yes. So what is it you have to do here? Yeah, what part of this tells you got to get it equal to 0? What part of this tells you that?
there's 2 x's.
Yeah, well, there's an x squared. There's a power higher than 1 on one of your x's. So your x terms are not like terms. If that was not a square, I would just make the 9x divided by 9 and be done with it. So when I can get my x terms all together, easy equation. Here I can't get these together. I need a different way to do it. So that's where you subtract the 4. And then, of course, here's where you got to remember, how do you do this?
Multiply the 2.
Yeah, so now I'm trying to factor this sucker. 2 times negative 4 is negative 8. If I factor that, it'll be 7, blah, 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 blah. Yes?
This is a different question. How would you know when to do the elimination process versus the substitution when there's two?
Oh,
two
all right. Is everybody cool with that one? Or is that, I didn't do that for you. I just want you to do something. If I have this, and I'm given a choice, who could tell me very quickly why I would never choose substitution method?
numbers are too big? Or,
How do you mean?
like the variables aren't. I mean
Every variable has a coefficient, which means when I try to solve for it, I'm going to divide, I'm going to make fractions. Which again, if I forced you to, you should be able to do it. You know, you're going to be like, oh, good, screw you, Jeff. But you're going to do it. But if I give you an option, I'm not going to do that shit. And again, like I said, I'm really good at math, but I'm not going to do fractions if I don't have to, because it's a really easy place to make a mistake. So here I would choose elimination. Elimination, I don't have to divide by anything. Who could tell me? This actually has an answer, by the way. To do this with elimination, what would I do? What's the whole idea of elimination? Why don't I just add these the way that they are? What's not going to happen that I want to have happen?
You're not going to cancel out.
No variable goes away.
Yeah.
So I'm trying to make the coefficients the same, just opposite signs. Notice how the x coefficients are already one of those things. So sometimes that's why I pick that one. You know, which variable do you pick? Well, just a lot of different reasons. Plus, the numbers are relatively easy. How do I make both of these the same number? It's the same idea as LCD. What's the first equation missing compared to this one? What would the LCD be between 5 and 2? 10. So you're going to double this guy and multiply this by 5. Won't they both be 10 and negative 10? Won't they cancel now when I add them together? I like it. So that motivates you. What's my purpose in this problem? Kill a variable. Well, how am I going to get there? I got to have these be the same, just different signs. Is that decent? So if I do this by 2, do this one by 5, and I add these together, y is negative 1, and then how do I get x? Plug it back into either one of these, right? You would get x equals 1. Is that decent? Do you guys see that? So that's a good question. How do you pick which one if I give you a choice? Well, there's the big kicker. If one of these, if that 7 wasn't there, I could do either way. You could do substitution because then I could just add 2x and I don't make fractions. I kind of feel bad for the people that do. They make all these fractions. They're desperately trying to do it, and all they're doing is wasting time. And I'm like, oh, man, shit. Yes?
And if the 2x and 7-1 and negative 9 were all out of order, you'd have to put them in order.
Yeah. You kind of want to line them up for yourself. If one of these was over there or something, yeah, you want to kind of line it up, which is going to lead to the idea of matrices. Remember, synthetic division is all about having it in order and putting a 0 if you're missing somebody. It's all about getting things in order. Matrices are going to take this and rewrite them, but everything has to be like terms lined up. Yeah. Which kind of follows what we want to have it happen as we do it. We want them to be lined up. Yeah. So remember, we have a quiz on this stuff tomorrow.
Maybe number 26.
Say again, which one?
26.
Oh, all right. Let me say this. What happens? Do you guys know what happens when you divide this by negative 1?
Flip the sign.
Why?
I don't know why. Because you're dividing the negative.
Yeah, but why? Why would you flip it just because you're doing that? I mean, that's what you were told to do, right? But why the hell do I do that shit? And you're like, because that's what gets me good grades. So yeah, when I divide by negative 1, I do have to flip this thing. I do. Why? Because. Look, let me show you. And that's not my real answer, but it ends up being my real answer. You ready? Go with me now. Which one of these is bigger? 2. Let's divide both sides by negative 1. What's this become?
Negative 2.
Negative 2. And the other side becomes?
1.
Which one's bigger now?
The 1.
Holy shit, the sign flipped, right? So really think about it. When you divide or multiply by negative 1, don't you change the side of 0 you're on? Doesn't the order change then? Whoever was bigger before is now smaller. Oh, shit. Do you guys see that? So multiplying, dividing by negative is called a non-order preserving operation. That sounds like a really fancy thing, but all it's saying is you switch the sides you're on, so you're going to change which one's bigger and which one's small. So what is a variable? A number I don't know. How's it going to act? Like any other number does. So why do I switch the sign? Because it happens. It just happens. Do you guys get that? All right. Never do something without knowing why you're doing it. Don't just do it because I said to. I could be insane. Again, I could be just some dude. I murdered the real Jeff. Oh shit, no. Don't look in the story. I planted to seed it down. Some people want to. Anything else from homework stuff?
On page 255.
You need 33?
Oh, 255 real quick. Which one? 30? Oh, cool, perfect. I love it. So when I ask you for domain and range, I do want answers in interval notation. All right, we talked a little bit about that. Remember the bracket is to include it because it looks like part of the letter I. The parentheses to exclude it because it looks like part of an open circle, right?
This is
7.1. This is page 255, section 3.8. That's the second part of the first homework stuff. Number 30, right? 30? Who asked that? You asked it. So now watch. If I had something like this, let me just do something really quick here. If I have a function, hi. All right. What's the domain of that function?
-1 and 2.
-1 and 2. Sure.
Inclusive.
Yeah, so inclusive both. Cool. Interval notation, what does that mean? What does that interval notation mean? Does it mean I only use -1 and 2? No, what does that mean? I use everything between -1 and 2. And how many things is that?
Right.
An infinite number. Right? You guys, so watch this. If I had of instead something like this, and that's it. What's wrong with writing that same answer here?
In a line.
Yeah, they're not all used. Is every x value used between -1 and 2? No, so this means everything between -1 and 2 has an output. That has an output. That has an output. You get a car. Right, this happened twice today. That's weird. Does every x value in between have an output? No, so you can't use interval notation for this because interval notation means everything in this interval is used. So what do you have to use instead? Who remembers? How do I list a set of numbers that are the answer to something? I use something called set notation. I just use this and list them. Right? So it'd be -1, 0, 1, 2. So when I have a finite number of things, I could put them between brackets. It just says those brackets just means the things that are in here. That's what you can use. Interval notation is a quick way to list an infinite number of things. Here I've got 4 things, so I can't use interval notation. Doesn't make any sense. Is that cool? So there are a few problems like that, the disconnected dots. But those are nice. You just kind of pick out the x values, and then the range would just be pick out the y values and put them into between brackets. I love it. Sweet. Okay, yes.
And this, would the same be for, I can't really remember the problem, but there was, it was, I think it was on the same page, and it was a picture that looked like that, and it had arrows. Would that mean it goes on for infinity?
Yeah, it goes on forever.
And if it had like a dot on something, does that mean it ends at a point?
So, I think the kind of problem you're talking about, there's one like this.
Number 36.
Yeah, that's a good example. Here's even another example. So which one is not going to be infinite in both directions, the domain or the range? Which one has kind of like a ceiling or a floor? The range. Isn't there a certain y value where the outputs stop happening? All right, so the domain is going to be, yeah, right? Because you're like, well, what about this x? When is that x used, Jeff? We'll just keep going, and it's freaking eventually used, right? Is that cool? But the range, what outputs happen? Well, they only go up to 2. From where? So the domain is going to be infinity to infinity. Never put a bracket on infinity, because again, that's freaky shit. Nirvana, so I don't know. You become pure energy. If you can touch infinity, I want to know what you took. What's the range here? What's the smallest output that happens? Negative infinity. Up to 2. Inclusive, because it's closed. Kind of like if it was an open circle, then you put a parenthesis. So is that the kind of problem you're talking about?
Yes. And then if those arrows were just dots, that would mean that's the
That they
endpoint.
stop
Mm-hmm.
somewhere. There would be a ceiling and a floor for the domain
Okay.
and the range. Yeah. So do you see what I mean by ceiling and floor? I'd say here that the range has no floor. Does that make sense? It has no floor. You walk into the house, you fall forever, infinite bit, oh shit, right? But there is a ceiling. You could throw a rope up there. Hang. I don't know. Sorry. I'll stop with the analogy. So I like the idea of ceiling and floor. We're going to see that happen a few times. Okay. I think somebody had a question. You good? Anything else from homework stuff? Okay, cool. So, let's get back into, what did I say? Tomorrow's quiz is going to be the 1 through 6 review, 7172. I like it. Let's do a couple problems from what we did in chapter 7 so far. Just truncate the question here. Where is this undefined? Where's this function undefined? Gotta get some new markers. How do you determine where this is undefined? What do you focus on when the question is undefined? The denominator. The top doesn't matter worth anything. It doesn't determine if it's undefined. To be undefined, a fraction has to have a 0 on the bottom. I only care about the bottom when the question is, where is it undefined? I really don't care about what the top is doing at all. So how do I tell? How can I tell where it's undefined then? What do I have to do with the bottom?
Factor.
Yeah, good. I like it. So make it equal to 0, because that's where it's going to be undefined. And of course, to solve this, I have to factor. I love it. How do you factor this?
X minus 7x minus 3.
Kick ass. So of course, it's undefined at
7 and 3.
7 and 3. I like it.
I have a question.
Yes.
So I briefly took this class for a couple weeks, and my professor wanted us to learn all the formulas for factoring. Like, I don't feel like he practiced that really, because he would like have us remember that. So looking at that, how would I know it's supposed to be 2 versus big guy, little guy, or twin?
Yes, I do. I totally do. I'm sorry if you feel that way. But yeah, we could go back. If your question is, Jess, can you remind me how the factoring works? I can work off of that.
I'm just trying to identify, how can I look at that and just know, okay,
All right. So you ready? You ready? So on the top of that sheet, and it's actually on the top of the factoring handout sheet that's on the website, you can print out for yourself if you want to. It tells you the number of terms, tells you what to try. What do you always try first no matter what?
Greatest common factor.
GCF. If it's got 4 terms, it's definitely a grouping problem. If it's got 2 terms, it could be one of 2 things. Squares. Or cubes. Is that cool so far? So, I mean, this is how you organize it in your head. So you have to know how each process works, but how do you identify when to use which process is the number of terms you see. So if it's got 3 terms, it's going to be either nice if it's a 1 out front, right? Which you really just figure out the numbers that make the 2 things work. Or it's going to be that surefire master product, whatever the hell you want to call it, if the number in front's not a 1. So since this has 3 terms, it can't be as cubes or as squares or any of that, right? So it's got to be, and since there's a 1 out front, it's just finding the numbers that make these things work. Yeah. Does that make sense? I mean, that's what to focus on. That's what tells you when to do what. the number of terms, exactly. That's why I put that right at the top, because it is the key thing. Now, of course, you have to know how each process works, which is the rest of that handout on the website, but the top is just how the hell do you know when to do what? Because that's the hardest thing in math, is I know how to do that. When do I do that? That's hard. But that part is not, you got to realize, that's nice. The problem is saying to you, hey, use this, here's how I work. You're like, oh shit, thanks, problem. Because that don't happen very often. So if I see something like, right, is there a GCF? No. How many terms are there? 2. I love it, because terms are separated by plus and minus. So what could it be? 2 terms could be squares or cubes. So which one is it? Squares. I love it. So then you can just forget about every other factoring at that moment and just focus on squares. What do I know about squares? Let me just focus on that. Because a lot of times people don't know how to categorize, so they just start trying anything. I'll see people start to do 9 times 25 and try to make something magic happen. No, don't call that. This is just squares. And of course, squares, please let squares be nice. You just have to cut everything in half, minus, plus. Is that cool? Okay. So yeah, this will just be 3xy squared minus 5w cubed. Everything in half. And then it would be 3x squared, xy squared plus 5w cubed.
And will it always be a minus and a plus?
Has to be. Why is it a minus and a plus? Because what's missing in the middle is the middle term's missing. They have to be minus plus, so they'll cancel.
And you wouldn't be able to do that if it was added.
Beautiful. So if I had, let's make it a little tiny problem here. If I had a sum of squares, I can't do that with real numbers, because how can the middle term cancel when the 2 numbers I'm going to put down are both the same sign? The only way to get 64 is either 8 times 8, they don't cancel each other, or negative 8, they don't cancel each other. Shit. If it was x squared minus 64, well then that's going to be 8 and negative 8. They cancel each other. That works. This one doesn't work for the same reason that does.
So then how would we work out that problem with a plus? If there's a
You would say prime, and you'd be done.
Seriously.
Seriously, yes. Look at how excited you are. Don't be too excited. If every other problem in the homework or in a quiz or a test is prime, you are wrong. I'm not going to do that, right? Do you understand? I can't figure out, it must be prime. It must be prime. Wow, Jeff, you made everything prime. That's crazy. No. At most, there'll be 1 prime, maybe on a test or a quiz. Is that cool? Now, let me show you one little slightly evil. Is that a sum of squares? Right? And did we just say you can't factor a sum of squares? But what is it that I don't give a shit what's going on? What do you always try first? GCF. And what comes out?
2.
More? 4. I like
Oh
it.
yeah, you're right.
And then you stop because that's a sum of squares. You can't do it. But the GCF can be done. Hell yeah, GCF doesn't give a shit what's going on. It's like everybody's got a 4. I can take a 4 out. I don't care what else is going on. But can I go further? Hell no. It's not a minus. Can't go further. I lock it. So this is what I mean. And a lot of times people do poorly in math because you don't realize what you should be focusing on is, why does it make sense? Why does what I'm doing make sense? Not, let me memorize this. No, oh my God, that's how you make a lot of mistakes, because you only got so much room. It gets all crossed over. Why does it make sense? Then it's less memorization, just doing what makes sense. Okay, maybe. Is that decent? All right. Yes?
And if so, if it was a plus at the start of the problem, then it would be prime, or would you have to figure it out first?
Yeah. So this problem, if this is the problem I gave you, and it said factor this, your answer would be prime.
Okay.
Hopefully you spell it right. Your answer is prime or can't be factored, something. Don't just leave it completely blank, because then I got to assume you didn't know at all what to do. Put something that said can't be done, or already factored, or prime is the best thing to say. I like it. I like it a lot. Okay. So it is true that factoring for this class is meant to be a review. I can certainly go over more problems involving it because, like I said the other day, all of Chapter 7 involves factoring. So and that's why I spent so much time yesterday on factoring. We did the whole factoring handout, right? Right? So trust me, for the summer, that's a decent amount of time. A whole day. Is there more factoring stuff you want to do right now, or are you guys cool for the moment? Cool for the moment? Okay. So continue with the Chapter 7 stuff, and actually going right off what I just was talking about. How would you simplify this? This poor little dude. How are you doing? You're probably just as bad. What you got, Jeff? Let's make this plus 64 though.
Ooh.
Notice it's a 3 though there, right? So the instructions say simplify this. So what do I do to start that off? Yeah, so you factor it. I like it, right? You got to factor this. You can't start saying, well, 2x's cancel. Why can't I just start canceling stuff? At 20 over 64, that reduces, Jeff.
Because there's a plus and a minus.
Because there's pluses and minuses. Division can't cancel parts of addition and subtraction. That's why, do you see how that makes sense? If I factor the top and the bottom, now I've got stuff that are multiplying. Now division can cancel parts of that. How do I factor the top there?
Negative 5 and 4.
Yeah, negative 5, positive 4. I like it. The big one's negative to make the negative in the middle at the end. And the bottom, of course, is going to involve
Cubes.
little dude, big dude. X cubed is
X times X.
x times x times x. 64 is 4 times 4 times 4. So what goes in the little dude?
X plus 4.
X plus 4, I like it. What goes in the big dude?
X squared.
X squared
Minus.
minus
4x.
4x plus 16. And so what can happen? Can anything happen there?
You could cancel the x plus 4.
Yeah, the x plus 4 is canceled. So you end up with x minus 5 over x squared minus 4x plus 16. You're just about out. Poor little dude. You write that in. X minus 5. Ooh, look at that. Yes, sir.
I have a question. Why can't you never factor big dude?
So the way that the middle guy is made, he's always going to be half. If he was minus 8, the bottom is perfectly factorable. In fact, let me show you something. I'm trying to still figure out how to incorporate this into how to teach this, but let me try to show you something interesting. The biggest mistake I see for how to factor this is something like this. Right? People are being, or even better would be putting a 4 there. Right? And on one level of me, I don't blame people because they're being optimistic. Well, there's 3 x's and 3 4's, Jeff. Well, how could that be wrong? Because if you FOIL these out, you're going to have a whole bunch of middle terms. Right? That's the way. The little dude, big dude is the way to make sure that all that middle term shit cancels. But notice, I want you to notice something. If I did start to multiply this out, this is interesting. Let me leave this one alone. What do you get here? You get x squared plus 8x. Is that cool? Plus 16. Do you see how that's very close to what the actual answer is?
Yeah.
Sort of? Do you guys kind of see that? So there is kind of a nice connection there, but to teach it that way from the beginning, I don't trust that yet. I'm trying to figure out if there's a nice way to teach that or if it helps remember how to do this. But this cannot work because now when I start to distribute, when I get a lot of terms, when I'm supposed to only have 2, right? Do you guys see that? This can't be the answer because when you multiply it out, you don't get this. You get a lot of other shit. All right, so the big dude can never be factored because the middle part of him is always half of what it would have to be. That's what makes everything kind of cancel. And the fact that it's the opposite sign, too. Okay, maybe. Okay. So that's how you simplify this. You factor everything and then cancel what's common. To be honest, this is exactly how we do numbers. We just normally don't have to show ourselves the factoring step. Right? If I said simplify 8 over 20, you would just figure out what goes into both and divide it, right? You wouldn't write down 4 times 2 over 4 times 5. But if you did, you can see totally what's happening. So that's exactly how we do this. Yes?
And for the answer, x minus 5, you wouldn't combine like the like terms with minus 5 and plus 16 because of the plus and the minus?
Totally not. Is the x minus 5 being combined with the x squared minus 4x? What are they doing to each other? They are dividing, right? So there's, like here, I wouldn't say 2 plus 5 is 7 because it's 2 divided by 5, right? Yeah, so these aren't combining with each other. They're dividing each other, yeah. That's why once I reduce it, I'm done. I can't do anything else. Okay, I like it. How are you guys doing? I see a lot of pained faces. Are you? Yes?
So you went about doing that because it said simplify. If
Yes.
you would have said solve, you would have done it.
It would never say solve for this problem because solve only makes sense if it starts off as an equation. And those are in our future. Equations with these things in them. But we're not there yet. So solving, I can't solve this because solve implies figuring out what x is. And since it's not an equation, x could be whatever the hell it wants to be except whatever makes the bottom 0, right? So there's no way to solve it, but I can simplify it. Okay, I like it. Okay. Okay, so, and then here is where we kind of left off. We left off with something like this, a 7-2 example. See if you guys get this here. I think I made a decent one here. Let's find out. So I want to show you something. That would be a 7-1 problem. This is a 7-2 problem, but it's kind of silly because it's the exact same idea. What's the one thing that's a little bit you got to be careful about? What's the main operation here? Division. And there's 2 fractions. So how do I divide fractions? Multiply by their reciprocals. Yeah. So I'm going to start factoring this stuff, of course, but I better also flip that dude, right? Same thing you do with just normal fractions with numbers in them. You do the exact same thing. You'd flip the second dude, right? And I showed you why that was true, remember? I tried to make sure you never do it that way, but I showed you why that's true. So just start doing this. See how far you can get. Just factor the hell out of everything and flip that guy.